In this video, we will talk about the Glbp protocol. So Glbp is a Cisco proprietary protocol, guys, and used for providing automatic router redundancy and load balancing. Okay, that is the key for Glbp, load balancing in IP networks. So it enables multiple routers to work together as a single virtual router for redundancy and load balancing. Okay, here routers share the same virtual IP address, but unlike HSRP and VRRP, multiple routers actively forward traffic to different end devices using different virtual MAC addresses. Okay, so traffic is distributed among active routers using a round-robin mechanism, optimizing network utilization. Okay, so the versions of the protocol are Glbp version 1 and Glbp version 2, which adds IP version 6 support. Glbp defines specific roles for routers participating in the protocol to achieve redundancy and the load balancing. So the first role is active virtual gateway. Okay, that is the gateway responsible for coordinating Glbp operations within a Glbp group. It assigns the virtual MAC address to other routers in the group, and there is only one active virtual gateway per Glbp group. Okay, the second router type is active virtual forwarder, AVF. So active virtual forwarder is actively participate in forwarding packets for different virtual MAC addresses assigned by the active virtual gateway. So each AVF maintains a forwarding table that maps virtual MAC addresses to physical MAC addresses of routers in the Glbp group, and multiple routers can be AVF within a single Glbp group sharing the packet forwarding load. When it comes to the comparison between Glbp and the HSRP, so HSRP, guys, that provides router redundancy with a single active router and one standby router. On the other hand, Glbp provides router redundancy with load balancing capabilities across multiple active routers. Okay, so that is the key differentiator. There is no load balancing in HSRP. However, there is load balancing capacity of Glbp. Okay, HSRP uses a single virtual MAC address per group. On the other hand, Glbp uses multiple virtual MAC addresses, up to 4 MAC addresses per group for load balancing purposes, and they are both Cisco proprietary protocols. So in essence, while both protocols provide redundancy, Glbp offers the additional benefits of load balancing traffic across multiple routers in a group, making it suitable for environments where maximizing network bandwidth utilization is important. So there are Glbp protocol states for virtual gateway and the virtual forwarder. Okay, so we have the disabled, initial, listen, speak, standby, and active states for virtual gateway, but virtual forwarder does not have the speak and the standby states. Okay, so for virtual gateway, there is a part, in disabled state, that is a part of Glbp configuration. It means like something configured, but the virtual IP is not configured yet. That is the disabled state. Okay, so in initial state, virtual IP is configured, but the configuration, all of the configuration for Glbp is not yet complete. So the corresponding interface must be operational in layer 3 and should be capable of IP routing. In listen state, hello packets are received by the virtual gateway. In speak state, virtual gateway tries to be active or standby. In standby state, gateway in this case is ready to be the active virtual gateway in case there's a problem with inactive virtual gateway. And active state means this gateway is active virtual gateway and responds to ARP requests made to virtual IP address. So how the configuration looks like is like this. So it's very much similar again, like compared with the HSRP and the VRRP. For example, instead of typing VRRP or standby, you go ahead and type the GLBP only when you're trying to configure it. So just pay attention to something in here. The virtual MAC address starts with 0007 and B4. That is the virtual MAC address of the GLBP protocol. Okay, so this is how it is calculated really, and you can go through if you are just more interested in. Okay, so but make sure if you just see a MAC address 007.b4, that means there is a GLBP protocol running router in this environment. Okay, so GLBP offers several load balancing options to distribute the traffic among active virtual forwarders within a group. So first one is round robin. That is the default one. So GLBP distributes traffic evenly in a round robin fashion among the active virtual forwarders, and each active virtual forwarder is selected in turn to forward packets, providing a balanced utilization of network resources. There is weighted load balancing that allows administrators to assign different weights to AVFs based on their capabilities or network conditions, and AVFs with higher weights receive a larger proportion of traffic, while those with lower weights handle less traffic. And we have the host dependent load balancing. GLBP can distribute traffic based on the MAC address of the host initiating the communication. That ensures that traffic from the same host consistently goes to the same AVF, enhancing the session persistence. So how I'm configuring it: GLBP group number and load balancing, and you just type the load balancing algorithm that you want to pick. So this is how we are configuring the GLBP authentication. It is again very much similar to the other protocols, and it supports the MD5 here also. And this is how we go ahead and configure the GLBP object tracking and the interface tracking as well. And pay attention, it is also very much almost the same thing with the HSRP and the VRRP. Okay, so we are coming end of the GLBP section as well, and thank you so much for listening to me. Let's meet in the other session.